Okay, good afternoon, good evening, good morning, all of you present here. Today we are going to learn about data pre-processing. Unit number two that have the topic of supervised learning and regression. Now, in this unit, we are going to learn about data pre-processing, dimensional reduction, feature subset selection. Now this is a part of dimensional reduction. A question for 7 marks can come here, definitely going to come here in paper about dimensional reduction. Explain dimensional reduction and its types. Now the next question that can come here is regression, about regression. So in this syllabus that is provided by RTMNU, we have mainly three types of regression, that is multiple linear regression, polynomial regression, and logistic regression. In this unit, we are going to learn about two regression, that is multiple linear regression and polynomial regression. Without wasting any time, we are going to learn about data pre-processing and dimensionality reduction. So I am going to refer here the notes that is provided by Dr. M.S. Khatib sir. This notes we are going to refer, and it is very systematically organized, and you can learn by reading the sentence and you will understand what is the meaning behind the concept. So the first thing comes here is data pre-processing. Now let's consider a machine learning model. For every machine learning model, we need certain type of data, right? So that the machine learning model can learn from that data. Now the data is in a raw data form. It might consist of garbage, irrelevant and redundant data that is of no use for the machine learning model. Now to avoid this, we use data pre-processing method. Now let's read out the first statement. What does the notes say here? Data pre-processing is a process of preparing the raw data and making it suitable for machine learning model. Making it suitable for machine learning model. So here is the point, that the data pre-processing is a process of preparing the raw data. The raw data that we are going to provide to the machine learning model so that we can make it suitable. It is first and crucial step while creating a machine learning model. It is first step, as the sentence says. The real world data generally contains noise. Now this point is subordinatory. You can write it on your own. You can read out this point and you will manage to write it in the paper. Now moving further, as the topic is data pre-processing, we have to process the data in a raw data form so we can make it suitable so that the machine learning model can learn from it, and the garbage data should be removed. So we have a method called as dimensional redundancy. Now let's see here. Now this is a database. Now database has n number of features here. Okay, so suppose this feature is called as age. Sorry, I don't have a pen. I only use mouse here, so my writing cannot be good. Okay. So age is called as feature. Now this whole entire column we would call this in machine learning language a feature. So there would be n number of feature. Now huge amount of feature is there. Now inside this feature there is irrelevant and redundant data. Now what is the meaning of irrelevant? Irrelevant. Wait. irrelevant data. Meaning of we are going to use these two words very much while writing the paper as well. Irrelevant and redundant data. See, I will read this definition here. Dimensional reduction is the process of reducing the number of features. The number of features that this is called as number of features, right? This entire column is called here a number of features. Now to reduce this in a certain way in a data set while retaining as much information as possible. So while reducing the feature, we shouldn't miss any important information, so that the machine learning model will have high accuracy. If we miss any important information, machine learning model will decrease in the accuracy. So to avoid that, we have to take this point under consideration while reduction of dimensionality. Now, in so this would be the definition that we are going to write in the paper. The number of input features, variables or columns, as well as attributes present in the data set is called as dimensionality. As I have told you, this entire database is called as dimensionality. Now, this data set will contain rows, attributes, columns, features. Now, to reduce this dimensionality, we call it as reduction, dimensionality reduction. Now, there are three. We are going to study about the components of. Let me write this. Components of what we are studying: dimensional redundancy reduction. Dimensional reduction. So the first component here is feature selection. Feature selection, or we can write it as feature subset selection. And the second one here is feature extraction. Now, feature subset selection will have a certain number of methods that we are going to write here. Firstly, we will see what is feature selection. Now, this is not all important, just go through it for once. The first part is feature selection. What is feature selection? Feature selection is the process of selecting the subset of the relevant features and leaving out the irrelevant features present in a dataset to build a model of high accuracy. Now, as we have seen here example, right? So we are given a feature of age. Now there is ages of people that is irrelevant. Irrelevant means that we cannot trust this data. We don't have this data is not trustworthy. Either it can be misinformation or valid information, but we don't trust it. And the second one that comes here is redundant data. Redundancy is the repetition of data. Now there in this certain age there are many students or employees or whatever the data set is about, that the age would be same. So that is considered as redundant data, the repetition of data. So to avoid this, we select a subset from this feature, and we select it uh, uh, using relevant data and not redundant data, right? And the remaining feature would be the remaining features. We would what is given here, and leaving out the irrelevant features present in the dataset to build a model of high accuracy. To build a model of high accuracy, machine learning model of high accuracy, we use this type of data. Now, the first method of feature selection is filter method, right? Filter method is a data set is filtered and a subset that contains only the relevant information is taken. Now the point here is no learning algorithm is employed to evaluate the goodness of the feature selected. This is high point that says about filter method. Now this filter method is just the definition of feature selection. Nothing changed. Everything is same. See, in this method, the data set is filtered, and the subset that contains only the relevant features is taken. Here also we take the relevant features, but the thing is we don't use any algorithm. To understand it more better, we are going to see the next method, wrapper method. Wrapper method is just as opposite as the filter method. See, this is the point, right? In this method, some features are fed to the ML model. Okay, now the features are selected. We have selected the feature, but we fed to the ML model and evaluate the performance. The performance decide whether to add those feature or to remove. So according to this performance, we are going to decide should we add this feature? Are the features improving the accuracy of the model or not? This method is more accurate than the filtering method but complex to work and computational expenses. Now, as the machine model is involved here, now definitely there would be involvement of certain computational expenses. So it is little complex to work and require computational expenses, and as compared to filter method doesn't use any algorithm. It just take the data set and use it, whereas wrapper method use the data set and you take the data filtered data set and perform and fed to the machine learning model and evaluate the performance. If the performance is good, we will consider the filter subset. If the performance is bad, we will not consider. But there are certain advantages and disadvantages for both of the methods. Some common techniques wrapper methods are forward selection. These are methods we are not going to discuss here. Now let's look at the diagram. Full feature subset, full feature set. Okay, full feature set. Select best subset. Now we are going to select best subset. Optimal feature subset. Learning algorithm performance. Simple diagram is given here. We are going to feed the algorithm, learning algorithm, the selected best subset, optimal feature subset. We are going to give it to the algorithm, and the performance would be the final performance of the algorithm. But here, see, optimal feature subset, and if it is not better, then we go in a loop here. Feature subset is given, generate a subset, feature subset is given. If it doesn't perform well, we are going to again generate a subset, and the cycle goes on until a better subset is performed. Now hybrid is nothing but the combination of wrapper method and this feature subset. Sorry, filter method. The combination of these two is called as hybrid method. Now the third one, embedded methods check the different training iterations of the machine learning model and evaluate the importance of each feature. It is quite similar to wrapper approach. See, wrapper approach, right? As it also uses an inductive algorithm to evaluate the generated feature subsets. However, the difference is that it performs feature selection and classification simultaneously. Okay, so see, the same diagram as given here, but we perform the feature selection and classification simultaneously. So this is going on simultaneously. The feature selection is simultaneously and the performance is going parallelly. Both of them are going parallel. It's finding a subset while the algorithm is performing the subset. So the waste of time is the time is saving. It saves time better than wrapper method. I'm going to read out this one more time. Embedded methods check the different training iterations of the machine learning model and evaluate the importance of each feature. It is quite similar to wrapper approach, as it also uses inductive algorithm to evaluate the generated feature subset. However, the difference is that performs it performs feature selection and classification simultaneously. So it's similar to the wrapper method. The only difference is that the performance it performs feature selection simultaneously and classification simultaneously. So just go with the word classification and feature selection simultaneously. Now next, feature extraction. So we to to know to get to understand better about extraction, we are going to compare it with feature subset selection. Now, in feature subset selection, what we do is, let's see in this diagram. Let's take it black. Now, this is a feature. Okay, this column represents feature. We take this feature, we take this feature, we take this feature, and we take this feature, and we take this feature. So this becomes our subset. Okay, so this is what, and we forget about this. We don't recall about this. This subset is deleted. We only remember this subset, and we consider this subset is our only final subset. This is feature subset selection. Now, what is feature extraction? Extraction is the process of transforming the space containing many dimensions into space with fewer dimensions. This approach is useful when we want to keep the whole information but use fewer resources while processing the information. Okay, we will take a little break here. I will read more about it, and then actually I don't know what is. Okay, guys, welcome back. We were left out at feature extraction. A feature extraction is nothing but a way of extracting a data from the dimension, extracting dimension in such a way that we don't reduce the dimension. We only reduce the computational cost. Okay, we only reduce the resources. Okay, so I will just read the sentence. Feature extraction is the process of transforming the space containing many dimensions into space with fewer dimensions. So, for with the first feature, right, we will go with the technique, then you will understand the meaning of feature extraction. First, we will go with the principal component analysis. So, then you will get a better view of feature extraction. Principal component analysis is the main method, not main method, but one of the widely used method in dimensional reduction. Okay. It is also methods of dimensional reduction as well as feature extraction. Now let's consider an example. See, we are given data with two dimensional, okay, 2D data, and we can easily recognize this data. But what if we are given a 3D data, three dimensional? Okay, so graph would look somewhere like this. We will have y-axis, z-axis, and x-axis. But it is also it is also understandable to our brain. But what if we have 4 dimensional data set? Then we cannot understand such high dimensional data. So we use principal component to make a high dimensional data into low dimensional data without any loss of information. Okay, and same thing is the definition of extraction. I will read it again. The process of transforming the space containing many dimensions into space with fewer dimensions. Okay, this approach is useful when we want to keep the whole information but use fewer res- sorry few resources while processing the information. Okay, we got the definition of feature extraction, and now we will see principal component in detail. Principal component analysis is the main linear approach for dimensional reduction. It is unsupervised method for dimensional reduction. This is a point right here. Okay, main linear approach. Linear means a straight line. Suppose 2D array is given, you can make a 2D array in a single linear line by using PCA, principal component analysis. It performs a linear mapping of data from higher dimensional space to lower dimensional space in such a manner that the variance of the data is the low dimensional representation is maximized. Now this is the point, a very useful point that you can write. Now the given is 3D array. Okay, this is a 3D array. 3D data set. Y-axis, z-axis, and x-axis. Now this is some data, like this points in the data plot. Now we will use PCA to transform this 3D data set into 2D data set. Now while using PCA, we will get such data points. This would be the an example of using 3D array to convert 3D array to 2D array while using PC, that is principal component analysis. Now you can see this here forms a cluster. Okay, this here forms a cluster between two groups of data points, and the difference between them is called as variance. Okay, variance is nothing but the difference between two data groups. Okay, variance. So what does the notes says here? It performs a linear mapping of the data from higher dimensional to lower dimensional in such a way that the variance of the data in the low dimensional representation is maximized. As I have shown you the example here, this was the data set in 3D, and now this is the data points in 2D representation, that is low dimensional representation. Hence the variance is increased while using PCA. The objective of PCA is to make the transformation in such a way that one, the features are distinct, that is the low covariance between the. Now, what is the meaning of covariance? Is nothing but similarity. Similarity between new features, that is the principal component, is zero. New features, this is called new features. Okay, this was our old feature, and this is the new feature, and the new feature here is called as principal components. and their covariance is 0. See, you can see zero covariance because both the groups are distinct to each other. The principal components are generated in order of the variability in the data that it captures. Hence, the first principal component should capture the maximum variability. The second principal component should capture the highest variability. Variability is variance, maximum variance. So the first, when we do the first iteration of principal component analysis, the first should capture maximum variability, and the second should capture the next highest variability, and etc. And the so on iteration goes. The sum of variance of the new features of the principal component should be equal to the sum of variance of the original feature. This is one important point. We will write till here in the paper, and after that it's all very complex, because there would be equation and something, so we are not going to read about it. Just till here we will write in paper, and I think the evaluator will give full marks. Now second concept we are going to learn, that is SVD, singular value decomposition. Singular value decomposition is a factorization method of a real or complex matrix used in linear algebra. We are not going to read it, learn entirely about it. We are just going to go through it. This and this topic, linear discriminate, discriminant analysis. Linear discriminant analysis. Okay, class. Now we are going to see what is singular value decomposition, SVD. Now SVD is related to linear algebra, so we are not going to go deep on this topic. We are going to just go through to the topic, and that is going to be enough for examination. So the first point here is that singular value decomposition is a factorization method of a real or complex matrix used in linear algebra. Now, what is a matrix? We are going to see here what is a matrix. Uh, Wait a minute. Okay, so given a table here, a table has n number of rows and n number of columns. So we write it as n into n. This is what a matrix looks like. Now n into n, right? So we, in this singular value decomposition, we write n as m into n. Okay. Now we have to find this. We have to find the value of this expression. So in singular value decomposition SVD method, we have a formula for this, that is m, sorry, u, and then summation or whatever it is called, u summation v. Am I right, guys? Yes. Look, SVD of a matrix A m into n is a factorization of the form u summation or whatever it is called v. So what is u here? I will go to the, what is u? U here is the first column, that the number of columns. Okay, that is m into n, and v here is the number of rows, that is n into n. Actually, the number of columns and rows are just n, but we are taking a square of this whole expression. that is m into m and n into n. So that, see, where U and V are orthonormal matrices, and U is an m into m unitary matrix, and V is an n into n unitary matrix. Okay, and this summation sigma, or whatever it is called, is m into m rectangular diagonal matrix. So this we can see a rectangular diagonal matrix. Okay, that is sigma, or whatever it is called. Now moving to this we have to only write this and don't go deep in this topic. And next we are going to study about linear discriminant analysis. See, the word analysis again is going to come in this method, and we have learned before a method that has his third word as analysis. And what was the method called? Principal component analysis. And what does that method used to do is it takes an dimensional data set and converts that into a low dimensional data without reducing any information. Okay, so we are going to do the same method here, but the only difference here is we are going to use supervised learning algorithm in this analysis, that is linear discriminant analysis, as compared to principal component analysis. In principal component analysis we use that is we used unsupervised learning algorithm. Now one more distinguish problem here is, however, see, read from here. However, unlike PCA, the focus of LDA is not to capture the dataset variability. See, we have seen in PCA one of the main mottos in PCA was to have a high variance in the data set. Okay, so that the data points can cluster with each other and there is no covariance between them. But in LDA, we don't have this. The main focus is not this. The focus of LDA is not to capture the dataset variability. Instead, LDA focuses on class separability. Okay, now what is class separability? It is separating the feature based on class separability so as to avoid overfitting to the machine learning model. Separating the feature based on class separability. Even I don't know what is the meaning about it, but just remember the point. Separating the features based on class separability. There is some attribute that is called as class. Okay, so we have to separate this data set with regard to class separability. Separating the features based on class separability to avoid overfitting in the machine learning model. So we have seen, okay, we will take one quick revision here. We have seen, let me just delete it. Components of, we have seen what is data preprocessing, we have seen dimensional redundancy, reduction, sorry. And inside this dimensional reduction, we have seen two main components, that is feature selection and feature abstraction. In feature selection, we have seen there are four main methods. The first main, the first method was filter method, and the second was second. What was second? Even I forget that. Let me just give me 5 seconds. Yeah, or even I can't remember. Yeah. I will wait till then. I will write the next one. Hybrid method. And the fourth one is embedded method. Wrapper method. Now I remember. wrapper method. So what was filter method? Method was nothing, just take a feature data set and directly use it into the machine learning algorithm. Whereas wrapper method used to take a feature subset and then use it on an ML model, and if the performance is good, it accepts it, or if not, then rejects it. Now, hybrid model is method is nothing but the combination of both of this, that is filter and wrapper method. Whereas embedded method is just like wrapper method. The only difference is that the process of feature selection and classification is goes on parallelly. That is sorry, what was that word? Parallelly, sequence? No, not in sequence. Parallelly is also, we can write it as wait a minute. Simultaneously. Simultaneously. Actually, what is the meaning of simultaneously? Am I wrong? At the same time, right? Parallelly. That is what I said before. Simultaneously. Now, what again? We were here, right? We have seen selection. Sorry, feature. Wait a minute. Feature extraction. In that we have seen three main features. And the first technique was principal component analysis, and the second one was singular value SVD, right? Singular value decomposition. And the third one was linear, I think linear something analysis, something linear discriminant. Discriminant. I don't know the spelling of discriminant. Linear discriminant analysis. In principal component analysis, we take higher dimensional data set into convert it into a low dimensional data set. It is an unsupervised learning algorithm, whereas linear discriminant is supervised learning algorithm. The focus of PCA is to have make low dimensional data into a high variance, whereas main focus of linear discriminant analysis is to convert it into such a way that it has the feature is based on class separability. Okay, so that the machine learning model don't have overfitting features. And the B is singular value decomposition. Here is the meaning of this is SVD. It is a it, what we say. It is a linear for a minute here. SVD. It is a formal factorization method. Factorization method of a real or complex matrix that uses linear algebra. Okay, it uses linear algebra, and we have seen the factorization form. If there is m into n matrix, then we take u and v, and then we solve it. Okay, so just go through it. Now the next topic that we are going to see here is important one, so I will just make it a heading. It is regression. Then we are going to see regression. I will take a 5 minutes break now, and we are going to learn about regression. There are four types of regression, but in our syllabus there is only three. Actually, there are five types of regression, but I will just see here. Khatib sir. What is regression? See, six types of regression, but mainly we will study simple linear because it is easy concept to understand. Multiple linear regression, we have to understand simple linear regression. Then we will go with multiple and polynomial, and then last we have logistic regression. Logistic regression is a topic of unit number 3, that is unsupervised learning, actually classification. Okay, but we will learn this here right now. I will take a 5 minutes break and then we will continue.